All right, let's get right into it. NVIDIA just dropped its roadmap for what they're calling the next industrial revolution. It's a huge deal. So today, we're going to break down their big GTC keynote and get to the core of what this all means, because it's a fundamental shift in how we think about computing, intelligence, and even manufacturing itself. And it all really kicks off with this one powerful idea from their CEO, Jensen Huang. You see, for decades, we've thought of software as a tool, right? Like a spreadsheet or a word processor that we use to get work done. But the new way of thinking is that the AI is the one doing the work. It's not the hammer, it's the carpenter. And that completely reframes AI as a new kind of production. And trust me, that changes everything.
So you gotta ask, why is all this happening right now? Well, according to NVIDIA, it's because the entire computing model that's powered our world for the last 60 years, it's basically run out of gas. The engine that drove all of our digital progress has just stalled out.
And that engine was Moore's Law. You've heard of it, right? For as long as I can remember, computers got faster and cheaper because we could just cram more and more transistors onto a chip. But that party is over. We are literally hitting the physical limits of what's possible. We can't just shrink our way to more power anymore. And this has created a massive problem. Because just as the demand for AI is going through the roof, the old way of powering it has hit a brick wall.
And this is really the whole point. The old playbook just can't keep up with the insane demands of modern AI. So this isn't about just making a slightly faster chip, it's about needing a completely new way of thinking about computing itself.
So what's the big solution? Well, NVIDIA's answer is to basically tear up the old blueprints and reinvent the computer from the ground up. They have a name for this strategy: extreme co-design.
And this slide just lays it out perfectly. A traditional CPU? Think of that as one really smart person doing tasks one after another, sequentially. But accelerated computing, using GPUs, that's like having an entire factory floor with thousands of workers all tackling different parts of a huge job at the exact same time. It's that massive parallel processing that AI craves. Now, yeah, it means you have to rewrite the software to unlock that power, but the performance jump is like going from a bicycle to a fighter jet.
And this is where their strategy gets so incredibly smart. Instead of just designing a chip and kind of hoping the software will catch up, they're designing everything in concert: the silicon chips, the systems they live in, the networking that connects them, and the AI software itself, all at the same time. It's this total holistic approach that lets them get those massive exponential gains that Moore's Law just can't deliver anymore.
So what does all this new computing power actually build? Well, it builds a brand new kind of factory. An AI factory, and the engine powering it is their new, groundbreaking Blackwell platform.
And the results of all that co-design? They're just staggering. The new Blackwell platform gives you a 10 times performance jump in a single generation. Look, this isn't just a small step up. It's a revolutionary leap forward that makes whole new kinds of AI possible.
Which brings us to the core idea here: the AI factory. The raw material it takes in is data. And the product it makes? It's pure intelligence. This intelligence comes out in little units called tokens. You can just think of them as the basic building blocks for AI-generated text or images or code. The entire purpose of this building is to just churn out these valuable tokens as fast and as cheaply as humanly possible.
Now you can imagine a factory that's producing intelligence 24/7 needs a colossal amount of energy. It's a huge challenge. And during his keynote, Jensen Huang actually touched on this, crediting the previous administration's energy policies. He said that recognizing the industry's massive need for energy was, in his words, a game changer for being able to build this new infrastructure at scale. The scale of this whole bet is, well, it's almost hard to wrap your head around. NVIDIA is forecasting $500 billion in revenue from these new platforms by 2026. This isn't just some new tech product. This is one of the biggest industrial build-outs in history.
Okay, but what's all this for? Why build these massive factories? Well, the goal is to become the absolute foundation for pretty much every major tech wave of the next decade.
And I mean, just look at the scope of their ambition. It is breathtaking. They're positioning these AI factories to power literally everything. We're talking next-gen 6G networks with Nokia, helping the Department of Energy bridge the worlds of classical and quantum computing. It's going to be the brain inside humanoid robots, the engine that standardizes self-driving cars. It's even being used for AI-powered cybersecurity and supercharging data analysis for companies like Palantir. It's everywhere.
So let's bring it back to the business side of things for a second. Because when you're building the infrastructure for an entire industrial revolution, well, the economics are just as massive as the technology.
And you know what? The demand is already exploding.
What you're looking at here is a comparison between their last platform, Hopper, and the new one, Blackwell. The demand for Blackwell is already 5 times higher. That's not just growth, that's a massive acceleration in the global race to build these AI factories.
And a really key part of their story right now is that they're bringing this critical manufacturing back home to the United States. The entire supply chain for Blackwell, from the silicon wafers being made in Arizona all the way to the final systems being put together in California, it's all being built up right here, domestically.
And you'd think with all this going on they might take a breather, right? Nope, they're not slowing down one bit. Even as Blackwell is just starting to roll out, its successor, which is codenamed Rubin, is already in the works for production next year. This shows they're committed to this relentless yearly pace of exponential improvement.
So if you take one thing away from all this, let it be this. NVIDIA isn't really a chip company anymore. They're building the factories that manufacture intelligence. And that leaves all of us with a really fascinating question to think about. If intelligence is a manufactured product, what happens to our world when the cost to produce it becomes so low that it's practically free,